Okay, moving on to Chapter 7, Lesson 2, we're going to be talking about powers of 10 and scientific notation. Our success criteria goes along with the exponents in this case again. So if we have x raised to the nth power, whether it's a positive or a negative, there's a couple of rules that we have to follow. If the exponent is negative, then we have to move the given decimal nth places to the left. Nth places being whatever the exponent is. But if the exponent is positive, then we're going to move the decimal nth places to the right. And the reason why this works is because if we have positive exponents, and we have a base 10 number system, and that simply means that we're going to be multiplying by powers of 10. 10 times 1 is 10, 10 times 10 is 100, 10 times 10 times 10 is 1,000, and so on. But if we have a negative exponent, then we're going to be dividing by powers of 10. So here's a quick example of how this works. If I have 10 raised to the second power, our 10 to the 0 power, we already learned in the last lesson, is 1. So that's our starting point of the base 10 number system. So I have 1. And since this is being raised to the second power, well, 10 times 10 is 100. So I have my 10 times my 10, which equals my 100. And when I go across and multiply that, of course I get 100. And if I have the starting point of 1, and it's understood that there's a decimal here, so that 1's in the 1's place. If I follow my criteria, if it's a positive, I'm going to move the decimal place the nth powers to the right. So in this case, it's 2 places to the right. So if I move it 2 places to the right, I have 100. If I'm doing a negative exponent, I'm going to do the opposite of that. Since I'm doing 10 to the 0 power, which we said is 1, and we're dividing by our 10 times 10, which is 100. I'm dividing by that, so I'm going to get 0.01. And to just demonstrate that again by moving my decimals, I'm going to have 1 in the 1's place, and since it's a negative exponent, please ignore my dog in the background, I'm going to move the decimal place 2 places to the left. So moving the decimal 2 places to the left, it would be 0.01. So that's just kind of how it works. Okay, so moving on, I'm going to give a couple of examples of what this lesson might ask us to do. So the first thing that it might ask us to do is to write each number as a power of 10. And I made a little note here. So if it's not giving me my power of 10, like these two examples here, is asking me to do that. So I have to kind of go opposite of what I just explained. So right now I have nice, simple, clean examples here. So when I move the decimal to the left, it's going to be a positive exponent. When I move it to the right, it's going to be a negative exponent, and I'll explain why that works in a second here. So we're going to write these numbers as powers of 10. So right now I have 1 million, and I need it 10 to whatever exponent. So it's understood, since I don't see a decimal here, it's going to be understood that the decimal is at the end of the number. So how many places am I going to move that decimal to get all the way to here? And you might be wondering why there. Well, one of the criteria are as well, and you might remember this from before, is that we have to have at least 1 digit in the 1's place. We have to have at least a digit in the 1's place. So I have to stop here to fulfill that requirement. 1 digit has to be in the 1's place. So how many places do I move the decimal? Well, I move it 3, 6, 7, 8. So it's going to be 10 to the 8th power. I moved the decimal to the left, didn't I? I moved it to the left. So that means it's going to be a positive exponent. So it's going to be 10 to the 8th. And the reason why this is a positive exponent is because if I undo what I just did, if they give me 10 to the 8th power, what is 10 to the 8th power? Well, then I'm going to start with my digit 1, my decimal's here, and I'm going to move that decimal 8 places in the positive direction, which in our criteria we said if it's a positive, we're going to move it to the right. So I have to move it 8 places to the right. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, and then place in my commas. And I should end up with that same starting number that I had to begin with, and I do. We're going to ignore that decimal because that's where I started. So I moved it 8 places, and now that decimal is here. Okay? The next example, writing this as a power of 10. So I have to have a digit in the ones place. So that means my decimal is going to come all the way over to here. So how many places does it move to get to that place, to fulfill that requirement of a digit being in the ones place? Well, it moved 1, 2, 3, 4, 5. So it's power of 10, and it's a 5, and I moved in the direction I want right, so it's going to be a negative 5. And again, it works because if I want to undo this, if I now fulfill this as 10 to the negative 5, I start with my 1, my decimal is here, and now I have to move it 5 places, and we said that if it's negative, we're going to move it to the left. Okay, so that means I have to move 5 places this way. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. My decimal lines up there, and again, it should match this, and it does, my starting number. And then finally, this one here, my 10 to the 1. Well, I'm going to move it, again, only one place, right? Because one digit has to be in the ones place. So what I have here is 10 to the negative 1. I only moved one spot to the right. And again, if I want to undo this, if I'm given 10 to the negative 1, I start with a 1, my decimal's here, and I move in the negative direction of 1, and that's going to put me right back to where I started from. So these are, they're all interchangeable. You can go either way, but it's just remembering that if I move to the left, it's going to be a positive exponent. Here, if I move to the right, it's going to be a negative exponent. So let's look at a couple more examples. So here we're going to find the value of each power of 10. So similar, it's exactly what we were just talking about. So if I have 10 to the negative 3, so I start with my 1 in my ones place, and again, my criteria says that if it's a negative, I'm going to move to the left. How many places to the left? To the nth power, 3. So I'm going to move 1, 2, 3. So there's my answer. So again, I moved 1, 2, 3 places to the left. Okay, 10 to the second power. So I start with my value of 1, and I'm going to move nth places to the right because it's positive. So my decimal is here. I don't want to mark the paper so it looks a little bit neater, but I'm going to move 2 places now to the right. So there's my answer for that one. And again, it makes sense because 10 to the second power is 10 times 10, which is 100. And then finally, 10 to the 0 power, this one's just, our starting number is always that 1. I don't have to move it anywhere. It tells me to the 0 power, right? So again, this is why a number to the 0 power equals 1. So there's your answer there. The next task you might be asked to do is to find the value of each expression. So on these ones here, you're going to take your given equation here. You got 97.86, and it's telling us to multiply by 10 to the 6th power. So all you have to do now here is you have your 97.86. And we're going to move that decimal, because it's positive, 6 places to the right. Okay, so 6 places to the right from where it started. So we already have 2 here. 1, 2, 3, 4, 5, 6. So my new answer now is going to be 9, 7, 8, 6, 0, 0, 0, 0. So really the decimal moved to that spot. Okay, and then my next one here is 19.5 times 10 to the negative 4. So what I'm going to do is my starting point is 19.5, and it's times 10 to the negative 4, so I have to move this decimal 4 places to the left. So I'm going to do that. 1, 2, 3, 4, so it ends up here. So I'm going to rewrite it correctly as 0.00195. So the big picture here is you take the number that's given to you and you're going to move the decimal to the nth place according to what's with this 10. That's all you're doing. Then finally you might be asked to write something in scientific notation. Okay, so again, this is similar to what I did in the first round of practice problems. If I move to the left, it's going to be a positive. If I move to the right, it's a negative. But again, remember the requirement. One digit has to be in the ones place. So it's understood that my decimal is way back here. I need to keep one digit in the ones place, which in this case is going to be the 4. Okay, so I'm going to rewrite how many places and where the decimal lands. So I know that the decimal is going to land here. Okay, how many places did I move it? So it was here, so I moved it 3, 6, 7. So now I'm going to rewrite it as 4.008, and I can drop the rest of these zeros. I don't need the zeros that are at the end. So I have 4.008 times my base 10, and how many places did I move it? How many places did I move it? So I moved it 3, 6, 7. So I moved it 7 places, and I moved it to the left, so it's going to be a positive exponent. Okay? And again, I can undo this and come back to that same answer if I want, because 4.008 times 10 to the 7th power is simply by taking this number, my 4.008, and moving it 7 places. 1, 2, 3, 4, 5, 6, 7. So to get that decimal back here, it goes back to that same starting number that I had. So they're interchangeable. And the reason why I'd want to do scientific notation is if you have very large numbers or very small numbers, they're much easier to write out in scientific notation. Okay? So this one here, again, I need one digit in the ones place. So in this case, I'm going to come all the way over until I have that 7 in the ones place. So I want to bring that decimal all the way there. Okay? So I'm going to rewrite it as 7.7. I know that's my starting point, times 10. But what is my exponent going to be? Well, I moved it to the right, so it's going to be a negative exponent. And how many places to the right did I move it? 1, 2, 3, 4, 5. So it's going to be a negative 5. Okay, and then I can check my work by moving this decimal 5 places back, and it should get me back to my starting point. And then finally, the last one is I only have to go to, there's one digit in the ones place. So I'm going to go until there's the 4 in the ones place. I want to get that decimal there. So I'm going to rewrite it, and it'll look like 4.12 times 10 as my base number system. And then how many places did I move it? Well, I only moved it 1, 2 places. And I moved it to the right, so it's going to be a negative 2. Okay? So again, I can go back and check this work. So again, this is, I believe I covered lesson 2 is pretty straightforward, you guys, and again, this is probably more of a review than anything for you. I know that you have done scientific notations and powers of 10 before. If you have your book at home, if you do have your book at home, I'm referring to the examples on page 452 through 454. If you do not have your book at home, these are the examples. I just did all of the examples for you, but if you need to go back and see, if you're more of a visual learner, you need to see what I did yourself, that's exactly where I got the examples from. So again, this is chapter 7, lesson 2, and I hope that helped. Contact your teacher if you need more help.